First of all, is the internet broken? Okay, we will break it today, and then we'll fix it. That's what we are good at, technical people. We will break and then fix it so we can justify our existence. Thank you. That's what we do, Jim, isn't it?
Exactly.
Right? We break things and we fix it. So today, I'm going to go through some of the high-level concept, and I want to keep it very casual. So please interrupt me, we can discuss, and then we can move on, as long as Bob doesn't give me a bell that we are going over time. I don't know how long this presentation lasts, so I want to kind of keep it very casual. And it's more of a discussion than that me presenting things. So there are things that I'm going to say probably you don't agree or you don't disagree. And it's not about just ubique. First of all, it's pronounced ubique. It's actually a Latin word. It's ubiquitous in Latin. So it's everywhere. So that's the core concept. So the concept, the topic that we're going to talk today is compute at point of need. We'll kind of find out what it is. So I call our generation, and kind of looking around, we are all kind of Generation X. And some of you are kind of more into Ys, but most of them are X. And we call ourselves as 100 millisecond generation. You know why? We can pick up the white phone or the crappy cell phone. Doesn't matter. It's expensive $1,000 phone, still it drops calls. It's crappy service, but we're okay. We're satisfied with it. Our tolerance for delay is not that big. We are satisfied with our VoIP call. Wherever you go, you got these Cisco phones, you pick up, 100 millisecond delay, you're okay. You kind of tend to be okay with it, because our tolerance for delay is 100 milliseconds. I call the next generation is the less than 30 millisecond generation. So this is the Gen Ys and the Gen Zs, or the millennials. The scary part is the millennials are getting into the workforce now. Like, if you're going to see them as coming as intern to your companies, at peers, and they're completely different. I don't know if you see your nephews and nieces and cousins, they're so fast. And if you look at them, they don't use voicemail anymore. It's all text or WhatsApp, and their tolerance for delay is 0. And they're here. That's the important thing. People think that, oh, they're kids and they're not here yet. They are in our workforce today, and probably you will see it in the next summer. And the kids born in around 2000s and kind of 2009, and they're going to be here. And when their tolerance for delay is 0, means that for them, delay means death. And people don't know what that means. You go on Google lag kills. You will actually get a t-shirt. You can buy t-shirts, mugs, and hats with the logo lag kills, because lag is a big problem, and for them lag means death. What that means to the business, lag means lost revenue. So if you want to market to those people, which is the next generation, those are the future buyers. Doesn't matter what you sell, you better have 0 lag. Otherwise, they're just not going to delay or wait for you to kind of give them the information. They will just move to the next aisle and buy stuff and go. So they have 0 tolerance. So what is the issue? I think we have 3 major issues, and this is the discussion, and we can actually think about it. And the first one is these centralized hyperscale data centers, and you've probably heard about them. These are Googles of the world, or Amazon and Microsoft, building these big data centers, basically like towns. And today what we do is we actually send the data to those data centers, and the servers process the data and send the result back. And that process for us is okay. Because we are 100 millisecond generation, we can wait for the delay, we can wait for the web page, and also kind of live through the dial-up world. And for us, we are just, this is awesome, what we have. Compared to what we had, this is fantastic. But for the next generation, it's not enough. For them, they can just wait. And if you think about mobile apps or any other stats, people actually leave app and go to another app because of lag, or if they don't get fast or response. Even us, I kind of talk about, think about Olympics and gold medal hockey and final game. It goes into the sudden death. and you know, as Sidney Crosby has the puck, and he's going to go into the goal and kind of he's shooting, the TV freezes. What is your tolerance for that? It's just zero, and you will just probably pick up the phone and scream at the provider and probably change the provider. Because even us, we are kind of, because we are getting, internet is used to be built for stuff that is not really matter to us before. Now, it's all about everything. Everything we do, we depend on internet. Our TV is now internet, our phone is internet, our 911 is internet, everything is internet. And you don't even know that it's internet, actually it is internet. It just goes there and then it goes into some sort of internet backbone. So that is the big problem. So sending data to the big data centers and bringing back is a problem. So, and also the amount of data we are generating, that's a lot. It's, you know, things called IoT, and every day, I think as a human race, we take so many pictures. The amount of pictures we take, I think in 2009, they did a study of the amount of data we created as human race is more data than we created from our day one, beginning of the human race, on that 1 year. So every year we generate lots of data, and we cannot send all these data to a centralized data center and process it. And actually me and Jim know very well, because we built these networks, there's no network to send this data. So if you want to have this IoT and all of these things work, sending the data to the centralized data center is not going to work. So we need to have a different solution for that. Okay. The next problem is internet is stuck in time. I think probably most, you know, there are people kind of can relate to this. TCP/IP. When was it, Jim? 1940?
It's even older than Bob.
So it is a very, very old technology, and unfortunately it's slow. It's very slow, but we are still stuck with it because the internet is built on it, and it's almost very hard to change. So we are stuck with TCP/IP. BGP is another protocol. It just never changed. It's invented, it's used, it's never changed. Same thing with IPv4. You know, they tried to do with IPv6, and it's a chicken and egg problem, and never changed. So we are stuck. In the data center world, they actually tried to overcome these problems by, if you guys are familiar with the data center, the InfiniBand technology, now RDMA over InfiniBand technologies. If you guys want to kind of go deeper into the technology, there are some technologies trying to bypass TCP/IP, but it's just in the scratch, like it's not actually mainstream. So we are stuck with it, whether we like it or not. There we are, and our internet is the general purpose internet. But unfortunately, we depend on these, you know, multiple decades, like probably 40, 50 years old technologies, and we are depending on it for our life. We are actually depending on it every day in our life. The next big problem, most of the people probably don't know. I actually asked my guys today, and most of the people didn't know. Internet is business. Even with the BGP protocol, even with all the slow TCP/IP. If I send a packet from here, let's say I'm connected to Eastland, I want to send it to, I want to talk to a Toronto Bell server. If you think logically, Eastland should have a connection with Bell Alliant, and Bell Alliant should just go to Bell in Toronto. It should be faster. That should be the direct connection. And if you let the TCP works, or BGP works, that's probably how it would go. But internet doesn't work that. Internet is business. It is based on business deals. So Eastlink will send the packet to the cheapest link. So they might actually have, I checked it today, they have a link from, I think Hurricane Electric or some other cheap provider. So it will go there, it will go to US, and that provider will decide what is my cheapest link to send it to Bell. They will send it there. Actually, when we were in One Docker Street, we actually kind of checked the Eastlink. It actually goes to US, to Vancouver, then come back to Toronto. Because internet is not optimized. Yes, unfortunately, we are depending on it, but the people in the middle make those decisions. And there are business deals made, there are different type of deals, cheap provider deals. So it's a completely, it's like, I don't want to call that, it is a small group, makes lots of decisions. So in many businesses like that, it's a pure business deal. So if you want to rely on the internet to deliver your performance that you need today, it's not going to be there, because it's the middleman going to decide how he is going to route your packet. So even with the slow things, we could have gotten a better internet, but because of the business deals in the middle, it doesn't work that way. And how do I know these business deals? Because I was there. I built these backbones. Actually, me and Jim were together. We actually made these deals. And we actually made lots of money for the company we worked for. We didn't care how the user is going to be impacted. As long as they can go to Google and Yahoo, we're okay. But the company made money. So that's how the internet works. So the problem for us, if we want to rely on the internet, or if you want to provide a service that you can get better experience, we can use the internet the way it is. So, conclusion is, the internet is broken. You guys agree with that? It is broken. It is actually broken in many ways, and we are stuck with it. And we are stuck with it, we just cannot get out of it. So that's why we created a technology. We call it compute at point of need. So we can't fix TCP/IP, or that's a completely different. There are lots of PhDs working on fixing TCP/IP. We cannot fix speed of light. If I have to send a data from Halifax to San Francisco, 6,000 kilometers, speed of light is speed of light. Every 300 kilometers, I'm going to get a millisecond or 2 millisecond delay. So I can't fix that. So what we said, why don't we flip the problem upside down? Why do I need to send the data to San Francisco? Instead of doing that, why don't I move the process to Halifax, for example? So this is not a new concept. It is actually a concept used in manufacturing. It's called, in economic theory, it's called space specificity. So if you have a GM plant, and the GM plant will have all the suppliers beside them, because they just don't want to have any delay. That's how it is done. But in internet, we just don't care. We just send everything to Amazon servers and bring it back. So we kind of try to apply that theory and move the server closer to the data, so we don't have to send the data. So that's what we call compute point of need. So our technology is called IQNet, and we can do that. And we are the first one to do that in the internet today. And we can move it to a closer point or to an optimal point. And it was very tough, but we managed to do it. And there are lots of decisions that goes on how to do that. So with that technology, where we can apply those technologies, important one is mobile. I think we can easily apply mobile. We actually see the phone that you have today. I don't know if you guys know, there's always 2 antennas. That's why you're paying $1,000 for the Samsung Galaxies. Because it's not just a screen, it has 2 antennas. Even with these technologies, voice goes through a different antenna, data goes through a different antenna. So they're not merged yet. So these providers are running 2 different networks to serve you for your data and voice. So very soon, that's going to merge. So with the LTE and everything, so the service providers are going to merge these technologies. So now, you're going to have just a data connection. So when you have the data connection, our idea is, why don't we just move all the phone into the cloud? So basically, think about your phone somewhere in Ubique technology. You just have a client that connects to the phone, and wherever you go, we can move it closer to you. So you're here, you're in Toronto, you're in England, you're in Australia, we don't care. We can just move it closer to you. So the technology can be applied very big in mobile. Video game, I'm going to talk about it because that's our day one focus. The reason is that we can create any technology, someone needs to pay for it. Otherwise, you will fail. So we found online gamers will pay for it today. Not just pay for it today, not tomorrow. So that's why we're actually focusing on online gaming, because the pain is so big. It's a $100 billion industry, and they will pay for it today. So that's why we're focusing on it, and I'll talk a bit about it. Video conferencing. big. I kind of see, you're kind of frustrated with video conferencing. Video conferencing was promised lots of things to us, Skype and Office, and still I cannot have a good video conferencing session. I cannot go to Skype and have a session with my sister in Sri Lanka, or even here, I can't have an office-to-office, without getting frustrated. I don't know you guys have, anybody have good experience with video conferencing, unless you have a dedicated network and a fancy Cisco, telepresence and, $1 million equipment. It's just impossible. But it's just not acceptable. I think video conferencing should be very easy, everybody should be able to use it, but it's not there yet. And so that's some of the things that we will be focusing on later. Video streaming, that's going to be big, you all know that, especially with the 4K streaming and everything, so that will be something. Retail is changing, it's changing big time. This is where that I actually joke with these kids. Today we go with the list and kind of go to, our way of shopping is completely different than the next generation. They're just going to go with the phone and get the answers, and they're going to get all the data, and if it's delay, you're not going to give them the data, they're just going to move on. So the traditional way of having the shelf arranged in a certain way and all these things all gone, because that's just for us. And the next generation don't care about how you arrange it, it's all about how you can give them the data fast enough so they can make the decision. So that's also going to change. Retail is changing big time. So our technology can be applied in all of these things. But we are focusing on online gaming. So we actually created a brand called Swarm here. Swarm Intelligence and Optimization. Because the way that our data centers work, we actually have our own physical data centers. We do have 3 today, Toronto, Chicago, and Seattle. And we have our own network connected. And people ask me, why not Amazon, or how come you're not using it? Because our background, we are the experts. And we can actually build and run a better cloud and better network than Amazon. And that's why we are doing it. And so the performance, this is where we are skipping the internet to fix the internet. So it will be some internet there, but once the people's traffic hit our network, it's ours. So it's not, so when we select a path, we are not going to optimize the path for cheaper or business deals. We are going to optimize it for the application need. So we are actually delivering the promise of internet. That's what said we, but we can't do it for all the applications. That's we can just slowly do it for one application at a time. So for gaming, when they hit our network, we will take over and we will optimize the routing and optimize the global location. So the way that we do today, if there's a game server, multiple players are connecting to the game server. Let's say someone from San Fran and New York and Halifax and Toronto connecting. We will detect those players where they're coming from. And we have an engine called optimization engine that's actually worked out with Dalhousie University. They're actually still helping us to build the algorithm. It's called optimization algorithm. It's based on swarm intelligence theory, where how the ants and bees and honeybees talk between each other to make decisions. And that's kind of a theory that we are using to optimize where the location is going to be. And then we will actually move the server. They wouldn't even know that. Or we will move the server, or we will initiate the session. So there are 2 things. So I'm not the big gamer, and these guys are the gamers, they understand. So when they go into a lobby and they are waiting for the players to connect, during the time we will detect where these players are from, and we will determine what is the best location. So for example, if people are from East and West joining, then Chicago will be the best location. So we will actually initiate the session in Chicago. So they will always have an optimal experience. So not one of them will have better experience or one of them will have less experience. So that's the idea. Especially with esports, the electronic sports industry where people actually play for money. So fairness is very important. So that's one of our major focus. So this distributed, we call it data center fabric. Eventually we will have the whole globe covered with our own network. And so we are now in East, So we have east, middle, west, and we are going to go into south, and very soon into Europe and Asia, and to cover with our own network. It's a big vision, a big network, and this is where I was telling people, we had a big group of people here, we are discussing, in order to monitor and manage this network is a global network and global infrastructure. So the number of people, number of talent that needed is a lot. So one of the problems that we have here, how do you get those people here to monitor and manage and operate this network? So this is one of the ongoing discussions that we have. With that, I want to go, probably this is the first group going to see a sneak preview of our May 15th release portal pictures. And I'll kind of show it to you guys. So we're going to release our portal. We care about everything, the design, the quality. We actually have a different core value qualities. Anything that we deliver has to pass those filters. It has to be innovative, it has to be leading, it has to be, we also have like, good enough is not good enough for us. So always pushing the envelopes. So here's our first preview of the portal, as this is going to be the registration and the portal. So initial games, we are going to target Minecraft and Counter-Strike, and people can log in and play the game, initiate your own servers, and bring your friends in, and then can have your private parties. We are also targeting some parental things, because we said, hey, if I want to buy for my kids, what are the features I want? I want to have all the chat logs. It doesn't mean that I'm going to look at it, but I just want to protect my kid. So there are features that parents need. We're going to give it to them. So it's kind of more secure, private, good experience for the kids. And when they log in, this is the second view of the portal. They will have all their social and all the games they can choose and go. So you guys are the first one to see it, and May 15th you'll be able to do that. So the Generation Z, they are here. I told you guys to talk and talk back. You guys were just listening, and I'm almost done. So they are here, and let's get the internet ready for them. Thank you.